This video is part of the lecture for online course on multivariable calculus, and I'm gonna talk about some examples of partial derivatives. So let me start by example 1. The function f is given as e to the power of xy. Find all the partial derivatives of that. So partial derivative of f with respect to x, I'm gonna treat y as a constant, and let me give you a recall. If we have e to the power of some number x, derivative of that would be a, the number e to the power of ax, okay? And so on here, I'm taking partial derivative with respect to x, so y is my constant, so I get y e to the power of x y. I use the chain rule basically. And partial derivative of f with respect to y would be what? I'm gonna treat x as a constant, so x and then e to the power of xy. Now if I want to find the second partial derivative with respect to x, okay, with respect to x, I'm gonna treat this as you see, this is a function of x and y, so I can take derivative of that with respect to x. Y is a constant, so I'm just gonna write y and then take derivative with respect to x, so I get another y e to the xy. And now if I want to take the second derivative with respect to y, let me move this one down here, I get what? I get, this is partial derivative with respect to x, I'm gonna take derivative with respect to y. With respect to y, I have two functions. I have this function in here, product with another function, so I need to use product rule. It would be derivative of the first one with respect to y, which is 1 times the second one, plus derivative of the second one with respect to y times the first one. I'm gonna write y, and I'm gonna take derivative of that with respect to y. So x is a constant, and I get this. Let me do for this one. I'm gonna take derivative of that with respect to y. With respect to y is x is a constant, so I get x squared e to the xy. And now the second partial derivative with respect to x would be what? With respect to x, I have two terms which are two functions of x, and I have a product between them. So derivative of the first one with respect to x, which is 1, times the second one, plus derivative of the second one with respect to x, so y is a constant, times the first one. Okay, since I have exponential function and I have polynomial, as you see, based on the Clair's theorem that we discussed, if partial derivatives are they are defined and they are continuous, fxy should be equal to fyx. What is this one? This is fx and then y, so this is fxy. This one is fyx, and as you see, these two are equal to each other. Let's go to the second example. Example, the function f of x and y is cosine of 3x plus 5y. Okay, what is f of y equals y? Okay, to find the solution of that, let me see. F of y equals y is what? It's f of y, then I take derivative of that with respect to x, then I take derivative of that with respect to y. So I need to start, actually, yeah, I need to start from y. I need to take derivative of this function with respect to y. I need to use chain rule. X is a constant, so for example, I have 30 plus 5y. Derivative of that would be 5. derivative of cosine negative sine of 3x plus 5y. Then if yx, I'm going to take derivative of that with respect to x. So y is a constant. With respect to x, I get a 3, so I get negative 15 cosine of 3x plus 5y. And if yxy, take derivative of this with respect to y. So with respect to y, x is a constant, derivative of that would be 0. So I get a 5, so it is negative 75. And then derivative of cosine is negative sine of 3x plus 5y. Okay, and the next example would be f of x and y, it's equal to the cosine of 4 over x e to the x squared y minus 4y cubed. And now let me take derivative of that with respect to x. With respect to x, I see that I have two functions in here, both of them they have x in it, so I have two functions of x and y, and so I need to use product rule. Let me write a and b. Based on the product rule, I need to have a prime b plus b prime a. So derivative of this one with respect to x, using chain rule, I have a number over x. Let me give you a very easy recall. So 1 over x derivative is x to the power of negative 1 derivative, negative x to the power of negative 2, which is negative 1 over x squared. So derivative of cosine of 4 over x would be negative 4 over x squared. Derivative of cosine is negative sine of 4x. So this is derivative of the first one. I'm going to multiply it by the second one, or the second term, y cubed. Let me bring this one a little down and here. And I'm going to have a plus sign. Now, derivative of this one with respect to x times that one. So let me write cosine of 4x first. I'm going to multiply it by the derivative of this one in here, which would be what? E to the x squared y minus 4y cubed. Now, derivative of the inside with respect to x, it would be 2xy. And then with respect to x, this is constant. Perfect. Now, partial derivative with respect to y. Derivative of that with respect to y is 0. This is constant, so it would be 0 plus, now derivative of that, so the first term was 0, the second term would be derivative of that times this, so it would be cosine of 4 over x times derivative of that with respect to y is x squared minus 12y squared, and then e to the power of x squared y minus 4y cubed.